Audin, che ci parla. Tu vas venir l'année prochaine parler du roman.
Oui, bien sûr.
Ah ouais.
C'est sûr.
Che parla di Sofia Kovalevskaya. Non so se tutti hanno presente le famose frasi del matematico Weil che diceva quella non è una donna e quella non è una matematica, delle uniche due. Beh, non volevo essere troppo. Cioè, insomma, lui diceva al mondo ci sono solo due matematiche cosiddette. Una non è una donna e l'altra non è una matematica. Alors, raconter les mathématiques autour des souvenirs de Sofia Kovalevskaya.
Merci, grazie mille. Do you prefer that I speak in English? Yes? Okay, so I can do that. Okay, so thank you very much for the second invitation, and thank you very much for coming to hear a second talk. I'm very sorry to. Okay, so when I was invited to come here, this was to speak about the book I speak of yesterday, and I said to Michele that I don't want to speak about this book, I want to speak about Kovalevskaya, and then he gave me two talks. That's a good strategy. Try it. Well, okay, so this talk is maybe in the same spirit as the talk of Roberto Natalini yesterday afternoon. It's about how to speak of mathematics to a large audience, non-mathematical audience. Okay, so it's about a book I wrote about on Sofia Kovalevskaya. I will speak mainly on Sofia Kovalevskaya, not about the book itself, but okay. And this was a beautiful book, which was very high quality of the paper and so on, and the printing and everything. And then it was translated in English by Springer. And they made it a standard Springer book. So if you read French, better to buy it in French. Well, let's go back to that. But in any case, it exists also in English. Well, so when I wrote this book, I wanted to speak about Sofia Kovalevskaya, but there are already several biographies available, mainly a biography by Anne Hilbert Koblitz, which is a very good book. But I was mainly interested in the mathematics of Sofia Kovalevskaya because this is exactly the mathematics, the kind of mathematics I was doing at that time. Mainly integrable systems in symplectic geometry. I want to be very more precise about that. And the idea was actually it's a general idea that I have, that we have to put mathematics inside culture, which is a good place to say that. In France, it was the case that mathematics was a part of culture, let's say until about 1920, I would say, and then disappeared. So I find it very important that science is a part of culture, just for obvious democratic reasons. I mean, if you don't understand anything, you cannot decide whether to use nuclear energy or not, or things like that. Okay, so people have to know a little bit of science. So why Sofia Kovalevskaya? Okay, so first of all, because she made some very interesting mathematics, and part of what she did is still actual today. I mean, there are open problems in what she did, and people are working on that. More or less, as you probably understood, I am interested also in literature, and she was also interested in literature. She wrote two two books, which are literary books. First, her autobiography, Souvenirs d'enfance, how to say it in English? What's the title in English? Childhood remembrance, or I don't know. And also she had a very romantic life herself. And I will go back to that. And also, I am interested in history, and I was especially interested in the history of Sofia Kovalevskaya's reputation. When she was alive, she had a very good reputation, scientific reputation. She was very well integrated in the mathematical community of her time, and I don't feel that that her reputation is as good as that nowadays. So I was trying to understand why. Well, so in this book there are lots of people. So this is a picture which is in the book. You are not supposed to recognize all the people in this picture. There are 36 people there. So probably you recognize Sofia Kovalevskaya, which is the first one at the top, and also okay. And also here it's her, and also where? I don't know. And also here. Well, and there are a few other people who take part in the history. I will come back to some of them in the talk. So Sofia Kovalevskaya, for those of who don't know, she was a Russian mathematician. She was born in 1850, and she died in 91. Sorry, but she was 41. That's the point. So this is what I include in the fact that she had a romantic life herself. I mean, it's very romantic to die at 41. It was very fashionable at that time. So she died from pneumonia. How to say that in English? Pneumonia. Okay, so it was, and she decided that she wanted to do mathematics. She was interested in a lot of things. In particular, when she was about 30 years old, she fell in love for Dostoevsky, who was a friend of her family, and when she tried to prove him that she was really in love with him, and she discovered that he was just asking her sister to marry him. So this was very very dramatic for her, and she tells that in her book. But she was very interested in mathematics and decided to learn mathematics and to go abroad to learn mathematics. So she was living in Russia, and to go abroad, she needed to have some social status as a married woman. So she found a guy who would marry her. She looked for that, and that was very common at that time. She was belonging to a circle of nihilist students, and it was very common to make this kind of marriages at that time. And so she married this guy. So I understand very well that why she wanted to do that, but I cannot understand why the guy would accept to do that. But she found a husband like that, and this was also a scientific. He was a student in biology, and he was the guy who translated Darwin in Russian. So somebody interesting. And then she was married, and she decided to. And then she left for Germany. And she went to Heidelberg, and she was a student in Heidelberg. It was not that easy, because if you wanted to go to follow lectures at the university, you first had to go to see the professor and ask him whether he will accept to have a woman in the audience. And if the professor says yes, you go, and otherwise you don't go. Okay. So she was a student in Heidelberg, and it was in 1871. And at that time, there was in Paris la Commune de Paris. It was a revolutionary movement in Paris. And her sister was involved in that, so she went to Paris during that time, which was not that easy. And so this was a civil war. You understand that there were lots of people who were killed there, and she was there at that time, and she was acting as a nurse for the wounded people. Well, so that's part of the romantic part of her life. And then she went to Berlin because the teachers she had in Heidelberg told her that, okay, we are so good that you have to go to see the master himself and you have to take lessons from Weierstrass. So it was not that easy because in Berlin it was worse than in Heidelberg. Women could not even enter the university. I mean, just open the door and enter. It was forbidden. So he accepted to give her private lessons, and he was teaching to her what he did in his course in the university, and she could attend that. And then she made a thesis that she passed in Göttingen. It was a thesis in absentia. She was not there, and it was. I will come back to what was in the thesis, but it was the beginning of her big achievement as a mathematician. So she had, and she was a European mathematician, and after the thesis in Göttingen, why Göttingen? Just because it was more liberal than Berlin, so it was easier to have a woman pass a thesis in Göttingen. And then there was some time where she could do nothing. She went back to Russia, and it was a very bad part of her life. And then her husband committed suicide, and this allowed her to become a professor at the University of Stockholm. And so this was at the end of the 1880s. And then she worked on the thing I will speak now about, and she got a prize of the Science Academy in Paris. So she was very well known. She was very famous, I mean. Okay, so what did she do in mathematics? There is a so-called Cauchy-Kovalevskaya theorem, which I won't speak about that, but it's okay. Cauchy just means, the name of Cauchy just means that it is a theorem about differential equations. The name of Kovalevskaya means that she stated the theorem and proved it. And that's it. I don't know how is it in Italy, but in France the theorems on differential equations are called Cauchy X. So an X tells you what theorem it is. So this one is. And then so there is in her thesis, there was a Cauchy-Kovalevskaya theorem, and there was also work on the shape of the rings of the planet Saturn. That's why there's this picture here. And what she did later to have this prize of the Academy of Sciences is to work on the problem of the rigid body, solid. Rigid body, so it was a very famous problem, and it was unsolved, and she was able to do great things about that. So you see the differential system that she was looking at. So you have six unknown functions: P, Q, R, gamma prime, gamma double prime, and then you have the fact that this is not a linear because you have this. QR, which is a quadratic, and so it's not nonlinear, so it's complicated. Okay. So there was these are pictures from the book, from my book. I mean, just to show you that it's a beautiful book. So. No, I mean it's really it was really there are beautiful pictures, and okay, that's okay. So it begins with the case of a spinning top, just a spinning top. Okay, so this was known This case was known, and it was integrated, the system was integrated in this case by an elliptic curve. And what she did is to find another case which is much more complicated, but also solved by an algebraic curve. Okay, I want, if you have questions, okay. And okay, so that's the Kovalevskaya top. That's called the Kovalevskaya top, the blue picture here. Okay, so, okay, I won't enter into detail there. This is for the mathematics, and this is the kind of things I was working about at the time. Not at her time, but at the time I wrote the book. And we have mathematics, and we have literature. So in addition to her book on her childhood, she wrote a novel, which is called Une Nihiliste. That's a French translation. I don't know if it's translated in Italian, but probably. But actually, it was translated in France less than 10 years ago. It's rather recent. Okay, which is a little bit autobiographic, but not completely. And but it's actually a novel. And also the paper you see that there is a paper published by the Swedish journal Acta Matematica on this problem of the rigid body. I mean, the equations you have here are taken from this book, this paper. Well, so these are the two aspects: mathematics and literature. So let me go back to the way I wrote this book. So there are many stories in the life of Sofia Kovalevskaya which were told and told and told again, and it was very hard to write it once again. And for instance, there is a story that tells that when she was a little girl, she was living in the country in Russia, and her parents have to repair the house, and they didn't have the paper to put on the wall in her room, and so they took paper that was there, and which was just a course on differential calculus, given by Ostrogradsky, because her father was a Russian general, and so he went to a military school and had calculus courses. And so they put that on the wall, and she was a little girl, and then when she learned differential calculus, her teacher was very impressed because she understood everything, because she had read that already when she was a little girl. So there are lots of stories like that I thought that everybody knows. It was not the case, but okay. So I tried to tell that, but maybe not. Some other way, non-linear way, let's say, like the equations were non-linear. First of all, and then I tried to put a little bit of mathematics in the book, but in a beautiful way, in the sense that she appreciated when she was a child to have these formulas on her bedroom walls, and maybe readers of the book would appreciate to see beautiful formulas. Who knows? And so I tried to emphasize beautiful formulas and pictures like these ones, which were rather mathematical pictures, but not too bad. And I tried to have that in the book, so that people see that there are formulas, and there are beautiful formulas. That a formula can be something beautiful even if I don't understand it. Okay, so that was the idea. And then, as she was also a writer and she wrote novels, I tried to put something, not only to write the book in a good way, but also to put some literature in the book itself. And so I decided to put some. I'm very sorry, but I didn't prepare this talk in English, and there are words that I don't know in English. So how to say pastiche littéraire, pastiche. It works in English. How is it? But it's an Italian word. It's an Italian word. Yeah, the pastiche. Okay. So there are some literary pastiche, right? In this book, and it was very hard to have a publisher publish a book on mathematics, on history of mathematics, and with a literary pastiche inside. So, but okay, okay, I found a publisher this time. It's not always the case, but I found a publisher, except that he published a book and he made a very beautiful book, but he's not very interested in the fact of selling the book. So that's another story. Well, so for instance, there is a novel by Jules Verne, which is called in French Sens dessus dessous, which is a story of a scientist who wants to, with a very big cannon, to shoot with this cannon, and in order to have the axis of the Earth change its direction, so that we have no more seasons, and we can grow things everywhere, and so on. So that's the idea. So this guy makes hard computations to compute that, and he's working with his computation, and okay, everything is done. The cannon shoots, but it doesn't work. It doesn't have the expected effect. And then the guy realizes that he made just a mistake in the computation. The computation is wrong, his computation. But why? Just because when he was doing the computation, he was interrupted by a woman. By the way, just a cleaning lady, but she was a woman. So it's because of a woman that. However, in this book, at the very beginning of this book, which is a very chauvinist book in some sense, at the beginning of this book, Jules Verne says that women do not understand anything in mathematics except for some Russian women. I know, but she was very famous. I mean, it's just because she was very famous. Some Russian women, it's just her. So I decided to write a pastiche of this book. No, I mean, it's very short. I mean, not of the whole book. At the beginning of the book, so the equations which are there are precisely the equations that Sofia Kovalevskaya solved to solve her paper on the rigid body. Well, okay. And also, she had the opportunity to go to England because her husband was translating Darwin, as I told you, and she was invited in George Eliot's house, and she participated to some meeting with people in George Eliot's house, and George Eliot had a diary, and she wrote that she came with her husband, and she had an argument with the philosopher Spencer, who was about women doing mathematics. She was very young at that time. She was 19 or 20, and so she was very young. And when George Eliot died, Sofia Kovalevskaya wrote also a paper about her, telling her how she remembered her. So we have the version of Sofia Kovalevskaya and the version of George Eliot. That's very nice. And there is a novel of George Eliot which is called Middlemarch, in which there is a very surprising sentence where she says that there is a guy in the book for whom the problem of the woman problem, whatever it is, was as complicated as the problem of a rigid body, an irregular rigid body. And most probably she learned about this mathematical problem from Sofia Kovalevskaya herself, and that's the reason why she mixed the women problem and the rigid body together. So I thought it was a good idea to have a pastiche of George Eliot, and as we are in Venice, the most beautiful pastiche I wrote was a pastiche of an Italian writer, Italo Calvino. So. Probably the people in the room, you have all read this book, Cosmic Comité, I guess. Everybody knows that. Or should I explain some? I guess there are at least one person in the room who doesn't know it. Okay, so So it's also about comics and sciences, I guess, as it was yesterday during the Natalini talk. Okay, so this is a book which is written like that. These are short novels. Every short novel begins with a small paragraph which is quoted from a scientific journal, which is a scientific text about astronomy or physics or the Big Bang, things like that. And then it stops, and then the story starts with this guy, which is called Krupp. How do you pronounce that in Italian? Krupp. And who says, no, it was not like that. Let me tell you at that time, and he explains you, for instance, that the Big Bang, it began because we were so tight that there was this woman there who says that if only we have some more places, some more space, I could cook tagliatelle for you. And then the Big Bang, and the text is really, really wonderful. I mean, really very poetic. There's a description of everything you need to have this tagliatelle. I mean, the sun and the fields and the corn and the rivers and everything, and that's really beautiful. And that's a very good reason why the Big Bang happened, according to Italo Calvino, who is one of my preferred writers. Although I read it in translation. Well, so I decided, as I love Calvino, and as Sofia Kovalevskaya wrote on the Saturn rings, I decided to write a pastiche of Cosmic Comics about the Saturn rings. So it's written. Okay, it's not as good as as a Calvino text, but it's written exactly like a Calvino text. I mean, there is this scientific thing about the shape of the Saturn rings. Laplace avait montré que la section des anneaux de Saturne était elliptique. So we look at the shape of. On pensait à l'époque que ces anneaux étaient liquides. At the time of Sofia Kovalevskaya, I think it was known already that it was not liquid. It was pieces of rock. But the work she did was a work on fluid mechanics, actually. So, okay. Ils n'étaient ni gazeux ni liquides, mais qu'ils sont constitués par des particules matérielles solides, discontinues, séparées par des intervalles très grands, une multitude de très petits satellites, mis en relation seulement par leur attraction réciproque, très faible relativement à celle de la planète. And then the guy appears and he said, pas du tout. That's not it. It was a liquid. It was like some cottage cheese. And so on and so on. And there is a story like that, which I like very much. And okay, so this was the way I wanted to explain you the way I tried to have a beautiful book about mathematics, speaking of mathematics, but not only, with different approaches, with pictures and formulas and literary text. And that's it, I guess. Yeah.